Okay, so what's happening in this question here? We have a value m that we're looking for, and we want this function to have a double root. Okay, so we can do this. We can kind of graph y equals 4x squared plus 24x. Basically, this has a 0 at 0 and 1 at -6, and we have a parabola that looks like this. Okay, that's not a very good parabola, but and if this m really all it is a vertical shift. So then there exists some vertical shift that I can move this up so it just touches the x-axis. Okay, so there must be some vertical shift that allows that to happen. So what is that vertical shift then? And how do I solve this algebraically? Well, I can kind of guess at it. In this case here, I have this issue of, I know if it's got a double root, so if it's going to look like this, if it's going to be a bounce like that, a double root, it means then that it must be a multiplicity of 2. So we have to have a squared factor. So we can actually solve this algebraically. Okay, and how do I solve this algebraically? Well, I know that it has to look like this. And if I want to make it look like this, really I'd need to know a and b. So this is one possible way we can do this. We can just say, well, I can expand this out, and I can say that f of x must look like this. The expansion of that's going to be a squared x squared plus 2ab, so ax times b, b times ax. Okay, so I get 2abx plus b squared. So really what I'm going to do is, this is a strategy called equating coefficients. I want to find m, and I can find m by solving for b. If I know what b is, I can then find m. I also know that this 4 must relate to that a squared. Well, if that's true, then I know that, and I'm going to write it over here, a squared is equal to 4. So a must be equal to plus minus 2. Okay, so if a is plus minus 2, then I've solved for part of it, but really I want b. But I can do the same strategy here and say, well, I can equate coefficients of this. This coefficient equates to this. If I know a, I can also find b. Okay, so I'm just going to color code this all. So this is from the green. And I can come up with one more equation. I can say that 2ab is equal to 24. I know that a is going to be, let's say plus, well, we'll say plus minus 2 times b. Okay, so b is equal to 24 divided by plus minus 4. So b could be plus or minus 6. Okay, so the question is actually technically not asking me to solve for b. It's asking just for the m. Okay, in this case, we kind of have the indication we probably should just assume it's plus b and plus a. But it doesn't really matter because it's being asked to solve for b squared. So I really just want m, okay, b squared or m. So if I've already solved for b, then I can say that b squared is equal to 6 squared, which is 36, and that must be equal to m. Okay, so there's my m value. And I can get that from equating the last coefficient. So this strategy is actually more important than the problem. The strategy here is maybe a new one that you've never seen. It's called equating of coefficients. So we can come up with equations or relationships based on the coefficients being equal. So this expansion and this expansion are equivalent. So this coefficient must match this one, so we can come up with an equation here. This coefficient must match this one, so we can come up with an equation here. This coefficient must equal this one, so we can come up with an equation here. So this strategy is called equating coefficients. Really what we could do is we could just kind of guess and test this. And if you know that this is a perfect square and understand the relationship between this, you could maybe have guessed 36 as well. We could also look at the graph and just move this graph up and down and show that that's also another way we can show that this is going to be 36. And we'll show that on the Desmos graph.